Hello everybody, my name is Leon Minghua. Today we're going to be talking about tides. So we've all seen it. Have you guys ever go to a beach? If you guys have and you guys ever wanted to take a bath in the beach water, you know what this is. You set your towel down on the sand, you go for a swim, and an hour later when you arrive, your shoes are floating away, like literally floating away, and we call it the tide. You see, when you look at images of the beach, things like that, you don't see the water level staying the same, right? You see it coming up and down, coming up and down, and sometimes there's sports like waters like waterboarding, etc. And those sports all rely on the tides. You guys have probably seen those crazy tides that could probably took away lives of dozens of people. And so, how does that happen? If you ask most people, they probably say that's basically the moon's gravity pulling the water, which basically we call it with the familiar name of tides. So here we're going to be looking at the cosmic tug of war between gravity and inertia, which are two very important physics characteristics of our Earth and our moon. Now first, let's start with easy part. What is gravity? Isaac Newton bring this to life. He told us that the closer two objects are, the stronger is the gravitational pull. So just imagine simply a random thing. The closer it is to the ground of our Earth, the closer will fall, the quicker will falls down. If you put it right up here, it will get pretty much slower. And so the ocean facing the moon is about 8,000 miles closer to the moon than the ocean on the far side, which imagine here is our Earth. And on the side is one ocean. On this side is another ocean. This is our moon. So which side will have a stronger gravitational pull with the moon? This side, right? And so because the water is closer, the moon's gravity will pull it more intensely, because that is what Isaac Newton told us. It literally stretches the ocean towards the moon, so it literally pulls just like tug of war, and this creates our first high tide bulge. If you're standing on the beach under the moon, you're standing in that bulge. And so now for the magic trick, the far side bulge. Why is there water piling up on the side away from the moon? Because we all know here's the moon, here's the Earth, this is one beach, this is another beach. So why is there still the water piling up on the side away from the moon, on this side? Now think of it like a professional hammer thrower in the Olympics. As they spin around, the heavy ball wants to fly outward, and that's what called as inertia. Now here, this is what we call as inertia, as I've mentioned earlier. The Earth and Moon are actually orbiting in a common center of gravity. And so as the Earth rotates in this cosmic dance, the water on the far side, this side, where the moon gravity is the weakest. So here is the strongest, here is the midpoint, and here is the weakest. And so where the moon's gravity is at its weakest, it tries to keep moving in like a straight way forward, and it flings outward away from the center of Earth. And so while gravity creates a bulge on the front side, it creates a bulge on the back side. And so the Earth ends up shaped like a football made of water. Pretty funny, right? So here, the water bulge stayed relatively fixed in line with the moon, but the Earth is spinning underneath them. And so if the Earth makes one full rotation every 24 hours, your specific city on the coast passes. And when you're in a bulge, it's called as high tide. But when you're in the gap between the bulges, it's called as low tides. And because there are two bulges, you pass through them twice a day. And it's like driving a car through two car washes on opposite side of a giant loop. Now here, the next time you see the ocean, remember you aren't just watching the moon pulling the water, but you're also feeling it. You're also feeling the balance between the literal glue of the universe, which is gravity in every object that has mass, and the relentless forward motion of inertia. And that was it for today. Thank you for listening. Goodbye.